Hello, this is Varomix, and today we'll learn about lighting in Redshift. Before we get into the magical world of 3D, I want to tell you something. Please study lighting in the real world. Any information you can find about lighting for photography and film directly applies to lighting in 3D. Understanding how light works in the real world will make your digital scenes way better. Alright, so let's learn about lighting in Redshift. We'll start with the basics, and by the end of this tutorial, you will have a render like this one. To create a light in Redshift, you can do it from the Redshift shelf. You can set an angle in the viewport first, where the light will be, and then control-click the RS Light button. That will position your light wherever your camera is looking at. You can see our created light there. The default light is a distant light. We can see this in the light properties. The RS Light in Redshift is an overlight. It contains several light types. The types are distant, point, spot, and area light. We will start with the distant light. This light behaves like the sun. It only matters where it's pointing at. We can see the light here in the render view is coming from this direction, and we have very hard shadows. Now let's look at the properties for this light. The properties here are basically the same for all lights, which makes managing lights very simple and fast. You can turn it on and off, hide it in the viewport. In the ray contribution section, we have options to disable the diffuse of the shaders. You can see if we turn it off, we are only affecting the reflectance or the specular. We can also turn off the specular, so now we are only affecting the diffuse. You can also control how much it affects the diffuse or speculars with these sliders here. We'll talk about the area, spotlights, and volume contribution sections in a minute. Let's go to the shader tab. This is where all the settings for the look of the lights are. We can change the color of the light just by clicking this color swatch, and I can pick any color from my light and see the result really quickly. You can also change the mode to temperature and change the temperature value by Kelvin scale. If you go to the left, the values get warmer. If you go to the right, the values get colder. This is what people mean sometimes when they talk about warm and cold lights. Then we have a multiplier for the intensity of the light. 10 will be more intense. If you make it 1, it will be less intense, of course. Then we have different unit types for the intensity. By default is image. Image is non-physical units. For the other modes, these come from the real world settings. So if you need to emulate a 100-watt bulb, you could do it here, or you can even use manufacturer's data to effectively use these modes. The luminous efficacy is how many lumens per watt our light is going to emit. Now let's continue to the shadow section. You can see right now we have a shadow. If we disable it, we don't have a shadow, either in the floor or the object. We can control the transparency of the shadow. If you don't want your shadows to be that dark, you can control that here. You can also control the shadow softness. If we pull this all the way up, you can see the shadow becomes soft, but it also becomes a bit noisy. And to control the quality of the shadow, we use the samples parameter. If we make the samples higher, the shadow becomes less noisy. Now we can continue with the rest of the light we have. Next we have point lights. Point lights are like spheres, emitting light in all directions equally. To make your light a point light, you just need to change the type here to point light. You can see in the viewport here I have 2 lights under the helicopter. The light will be going in all directions from the center of this sphere. In the render view, you can see how light goes in all directions. All the parameters we discussed before apply for this light as well. Plus, we have a decay parameter. This is how the light decays on the scene. I recommend you always leave it at inverse squared unless you have a specific effect you want to do. This is how light decays in the real world. If you change this to none, the light will never decay and will illuminate the scene forever. If you make it linear, you have these sliders to control the fall of start and end and make some special effects if that's what you need. Now let's move on to spotlights. Spotlights are a very common type of light used for lighting. To make your light a spotlight, you again just change the type. Now let's see this light in the viewport. We can see the 3 lights illuminating the scene. This one looks like a disc light, but it's actually a spotlight with a really large cone. Now let's see what are the options that we have for spotlights. As you can see, we have the same parameters as we did before, plus this new cone angle parameter. There's also another parameter in the shader tab, the fall of angle. This is basically smoothing the cone edge. If you raise it, the edge is softer. If you lower it, the edge is sharper. Now let's talk about area lights. Okay, so I have one area light enabled right now, and you can see this light looks very natural. Area lights tend to simulate light in the real world very nice. Let's go to the viewport. You can see I have this really big square of light coming from this direction. If you know lights in the real world, this is like a really big soft light. Now let's see what parameters we have for area lights. Again, to make your light an area light, you just change the type here. Now we have this area section enabled. First, we can have different shapes for area lights. We have rectangle, disc, sphere, cylinder, and we can even have a mesh that illuminates the scene. The area size is just the size of the object in your scene. This will actually affect how it illuminates your scene. If I make this smaller, two things will happen. The area light will become dimmer since the light is coming from a small object, and also the shadows will become a little bit more sharp. If I go back to the size I had it, the shadows are softer now, and the amount of light emitting from that rectangle is a lot more. You can make this light visible if you want to render the actual area light shape. We could make it a sphere, make it smaller, and put it in front of the camera, and now in the render view you can see the actual shape of the light. If I don't want to see the light, but I still want to have the light there, I can just disable visible. There's also a bi-directional option. This applies more for flat shapes like rectangles. This means that light will be emitting from both sides of the plane. By default, it only emits from the front face. Normalize Intensity tells Redshift to ignore the actual size to calculate the intensity. So if you turn this on, you control the intensity here in the shader tab, and the light can be any size and will always illuminate the same amount. The samples controls the quality of the light. You remember that in the other types of lights we control the shadow samples here. This doesn't apply to area shadows. For that, we'll use the samples here. If we make the samples higher, you can see the quality of the shadow is better. Also, if we go back to the shader, the softness won't have any effect on the area shadows. That will be controlled again by the size of your shape. The samples won't have any effect here. The transparency does work. If you want to make your shadow transparent, you can do it here. If I enable a few other area lights, you can see the very nice lighting we can get. It's just a few lights, a few from the side, and one from the top, and we can get this nice render. The next light is the dome light. To create a dome light, you just go to the shelf and click the RS Light Dome icon here. It creates a dome light in the center of your scene. It's just a little sphere representing the dome light. Now that we created the dome light, let's see what effect it has in our scene. The dome light is a really large dome that emits light in every direction towards the center of your scene. In the light tab, you can see the parameters are very much the same as before. You can turn the light on and off. These samples are the same as the area lights. If you need more samples on your shadows, you will use this value here. The specific parameters for this light are in the shader tab. To start, you can plug a dome up here. Generally, an HDR texture, and this is how you illuminate scenes in Redshift using HDR images. You can select the type of map it is from this drop-down. You can adjust the gamma, tint the image, and set the intensity of the illumination. You can even override the gamma, and again we have a transparency setting for the shadows and an environment alpha channel to replace the alpha of the image that we're applying here. The backplate tab is used if you want to use an image to be rendered as a background with your scene. Alright, so let's see an example of this using an HDR image. Okay, just by using an HDR image, you can see we have very nice lighting in our scene, and even a direction of the sun coming from the image and a nice shadow. We can control the rotation of the image. This way, you can set the direction of the lighting you need, and you can see this is really quickly updated in Redshift. I have another dome light with another HDR image here. Again, we can rotate it and see really quickly the results. You can even combine these two or more dome lights and create different or more artistic lighting setups. Now let's do some global illumination. Redshift has amazing global illumination engines, and it's pretty simple to use. I'm just going to use one single direct light and that's it. In the render view, you can see we have just direct illumination from this side, and all these areas that are occluded by the model are of course dark. We can solve that by turning on global illumination. Let's go to the Redshift ROP, Redshift section, global illumination, and we can select from one of 4 engines here. We'll select brute force. Just by selecting that, you can see how much better the image looks. Now we have light bouncing inside the dark areas. It's important to know that we need to set a secondary GI engine to have more than one bounce. If we select now a secondary engine, for example Irradiance point cloud, now we have more bounces of light. To control the quality of the engine, we have the brute force GI rays here. If I set this to 64, you can see we now have a really nice clean render. Each engine has a tab for their specific settings as well. Another type of light we have in Redshift is the mesh light. You can see I have this mesh object here in the viewport. If I want to emit light coming from that object, I can use the mesh light. Just create another light, place it wherever you need it, change the type to area light, and then the shape to mesh. Then just plug the object here, and we can just drag it. Now the light takes the shape of the object. We can render it, and this is what we have now in our scene. Mesh lights are better to use instead of making something very emissive, because you have the samples here so you can control your light better. And of course you can go to the shader section and change the color to any type you like. Alright, now that we saw most of the light we have in Redshift, let's see our final project. So let me enable all these lights I have here and render it. Alright, so I have a few lights here in my scene. Let's go to the viewport and see what we have. You can see I have one huge large area light here. I have a spotlight here from this direction. I have a light here for the antenna. I have 2 lights here in front for the front lights, a few lights in the bottom, and a few other lights here in the legs, which are these ones. Even this laser here in front is just an area light with the cylinder shape. Now if we go to the Redshift node, Redshift and volume, and enable the volume, now you can see this gets really interesting. Now my lights are contributing to the global volume here in Redshift because they have this contribution scale bigger than 0. Now I can control how much each light contributes to the volume here. These lights on the legs are just air lights as a cylinder, and you can see I'm again contributing for the volume there. If I make this higher, you can see this is going to contribute more on that volume, and it's going to illuminate way more. So you can do this for any one of these lights and tweak how much you want that light to illuminate the volume there. Alright, so now you know how to light your amazing scenes in Redshift.